So student, this is the second part of my video. In this video we will discuss the remaining equations and remaining mathematical steps of the barometric formula. So we have already discussed these equations in a first video. So this equation, as we know, that minus delta P, which is equal to rho into delta H into G. So as we know that in the previous video we will discuss about this equation. So this equation is on Pm over RT, which is equal to rho, and when we put the value of the rho into this equation, then this equation becomes minus delta P, which is equal to Pm over RT into delta H into G. So here P is multiplying with M, and when we transfer the P into another side, then at the other side it will be dividing by the delta P. So this equation becomes minus delta P over P, which is equal to mg over RT into delta H. So now we integrate these equations in the limits P naught to P and 0 to H. So when we integrate this equation, then this equation becomes, we finalize this equation. So here negative sign is going with this equation. So when we transfer the negative sign into another side, then this equation becomes delta P over P, which is equal to minus mg over RT into delta H. Now we want to integrate this equation in the limits P naught to P and 0 to H. Then we put the integration signs with the limits, so on both sides. So when we put the integration sign on both sides, then this when we finalize this equation, then this equation then becomes ln of P in the limits P naught P, which is equal to minus mg over RT, is any constant. So we take it on the other side, and when we integrate the delta H in the limit 0 to H, then this equation becomes this equation becomes H limits H over 0. So when we finalize this equation, then this equation becomes ln P over P naught. Here we applied the rule of the log, so we get ln P over P naught, which is equal to minus mg over RT, and when we applying the upper and lower limits in this equation, then only H is remained. So final equation becomes ln of P over P naught, which is equal to minus mg over RT into H. Taking antilog on both sides in this equations, taking antilog on both sides, when we take the antilog, ln is a log, and when we take the antilog, so both are cancelled to each other, then final equation becomes P over P naught, which is equal to e raised to power minus mg over RT into H. So here P is dividing by P, and when we transfer the P naught into another side, then at the another side the P naught will be multiplied with the e raised to power minus mg over RT into H. This is the H, not N. This is H. In the form of the density, this equation can be written as rho, which is equal to rho naught e raised to power minus mg over RT into H, and in the total mass or moles of the gas. So we know that the moles of the gas, which is equal to mass over molar mass. So now we write this equation in the total mass of the gas. So this equation becomes N, which is equal to N naught e raised to power minus mg over RT into H. This is the H, not N. This is the H. So now we will talk about the graph of the barometric formula. When we plot the partial pressure ln P over P naught on a y-axis versus height on the x-axis, then we are observing that when we increasing the height, the pressure is decreasing. When we increasing the height, the pressure is decreasing. This is the graph of the barometric formula.